Hello everyone, today we're going to study a new lesson concerning the literal fractions. Please stay focused and let's start. First of all, we have to know that a literal fraction is a fraction that contains variables or unknowns denoted by letters. But in this case, the fraction must be defined, and it's defined when the denominator or the result of the operation that exists in the denominator is not zero. Because we cannot divide any number by zero, and this is impossible and counted as an error in math. An example for a literal fraction is the following. When we have 5a over 7b, why it's a literal fraction? Because it contains two simply letters in its numerator. Here's some solved operations as example for the literal fraction. So the first example is when we have to add two literal fractions. If we have two literal fractions having the same denominators, we just add the two numerators together and the denominators stays the same. So a over b plus c over b is too simply the result of a plus c over b, with having b different to 0. And in each fraction we have to mention that the denominator is different to 0. The same thing happens when we have to subtract two literal fractions having the same denominator. So the numerator of the result is the result of a minus c over b, which is the same denominator, with mentioning of course that b is different to 0. Here we have also a over b plus c over d, so we have different numerators and different denominators as well. So what do we have to do? We have to simply to unify the denominator. As we said, we have to have the same denominator in each fraction. So the first fraction we multiply it on the top and on the bottom by d, and the second one on the top and bottom by b. Why did we do that? To unify the denominator. So b times d here and b times d here. And now we can add these two fractions by simply adding the numerators. So the final numerator of the final fraction, the result fraction, is a times d plus b times c over the denominator, which is b times d, with of course having b different to 0 and d different to 0. We have to mention that both b and d, each one is different to 0, because b and d in this operation are multiplying each other, and we have to get the resulting denominator different to 0. So we have to mention each one. The same thing happens when we have to subtract two literal fractions as well. So we have to first of all unify the two denominators, then we just subtract the numerators and we get the final result, with of course mentioning the denominators different to 0. What do we have to do when we have to multiply two literal fractions? We have to simply to multiply the numerator of the first fraction by the numerator of the second fraction, and the result becomes the numerator of the resulting fraction. And we have to multiply the denominator of the first fraction by the denominator of the second fraction, and the result becomes the denominator of the resulting fraction. So a over b times c over d is equal to simply to a times c over b times d, with mentioning of course that b and d, both of them, each one of them is not equal to 0. Okay, the last one, a over b divided by c over d. What do we have to do when we have to divide two fractions? Too simply, we have to multiply the first fraction by the reciprocal fraction of the second one. What is the reciprocal fraction? is when we switch the numerator and denominator. So the numerator becomes denominator and the denominator becomes numerator, as we see here. So it comes a over b times instead of division, the reciprocal fraction d over c. So a over b times d over c becomes a times d over b times c, the numerators together and the denominators together. Also, of course, we have to mention that the denominator. Another example, we can have a look. 2 over m plus t over n is equal, after operating and unifying the denominator, to 2n plus tm, all of it divided by mn. Here. The second one, we have to multiply these two fractions. So we to simply multiply the two numerators together. We don't forget to multiply the signs as well. Minus times minus equal to plus. And we also multiply the two denominators together. So 5y times 6x is equal to 5 times 6, 30, and x times y is equal to x times y here. And to simply we can remove the xy from here and xy from here to get 20 over 30, which is equal to 2 over 3. The third one, we have to divide these two fractions. M over n divided by n over m is equal to, as we said previously, m over n times the reciprocal fraction of the second one. So m over n times m over n as well. And it becomes a third. And this is called the compound fraction. When we have to divide two fractions is to multiply the first by the reciprocal of the second one. And this is the compound fraction. The form of the compound fraction is a over b over all of it over c over d. So an example for it, 3 over 7, all of it divided by 2 over 5. So it's equal to 3 over 7 here times 5 over 3. So it's equal to 3 times 5, which is 15, over 3 times 2, 7 times 2, which is 14. Remark, when we have a letter or a number without any denominator, we can suppose that the denominator in this case is equal to 1. Because when we divide any number by 1, the result is itself. So a over b divided by c is equal to a over b divided by c over 1. That means a over b times 1 over c, which is equal in the end to a times 1, which is a, and b times c, which is bc. We have to mention that b and c, both of them, are not equal to 0. When we have the same thing here without a denominator, we suppose it 1. So a over 1 times c over b, which is equal to ac over b. And here in this case, we have to mention that b is not equal to 0. Thank you for your listening.